Hi, this is Osama Al-Amrani. I am a 9th grade student at Al-Nakhda Modern School in Sana'a, Yemen. In this episode, I will talk about arcs, chords, and inscribed angles. Ever wondered how the ancient Egyptians built their perfect pyramids or how the Greeks designed their magnificent temples? Well, it all boils down to geometry. This fascinating field of study, which dates back to the time of the ancient civilizations, has been the backbone of countless architectural wonders and scientific breakthroughs. It's more than just a collection of lines, shapes, and angles. It's a language that describes our world. Today, we'll be exploring 3 key concepts that form the bedrock of geometry: arcs, chords, and inscribed angles. These aren't just abstract ideas confined to the pages of a textbook. They're vital tools that engineers, architects, and scientists use to solve complex problems and make sense of the world around us. So whether you're building a skyscraper, designing a roller coaster, or simply trying to understand how a rainbow forms, you'll find that these concepts come in handy. So buckle up as we dive into the world of geometry, starting with arcs. Picture a slice of pizza. That curved edge, that's an arc. Now let's dive into the world of arcs. An arc is a portion of the circumference of a circle. Imagine you're drawing a circle and stop midway. That line you've drawn, my friends, is an arc. It's like a piece of the circle's edge. Let's talk about the properties of an arc. An arc is defined by 2 things: its length and its degree measure. The length of an arc is simply the distance along the curve, while the degree measure is the angle that the arc makes at the center of the circle. Now let's say you want to calculate the length of an arc. How do we do that? Here's the formula. The length of an arc equals the degree measure of the arc divided by 360, the total degrees in a circle, times the circumference of the entire circle. Sounds complicated? Let's break it down. Picture a clock. The minute hand moves from 12 to 6, that's halfway around the clock, right? So you have a 180-degree arc. The circumference of the clock, let's say, is 30 centimeters. Plug these numbers into our formula, and voila, you've got the length of the arc. But what if you don't know the circumference of the circle, just the radius or diameter? No worries. Remember, the circumference is just 2 times pi times the radius, or if you have the diameter, it's diameter times pi. Easy as pie, or should I say pizza. Speaking of pizza, let's go back to our slice. The curved edge, our arc, is a fraction of the whole pizza's circumference. Each pizza slice represents a degree measure, and the full pizza is a complete circle of 360 degrees. So, the next time you grab a slice of pizza, remember, you're also holding a perfect example of an arc. You might have heard of chords in music, but did you know there are chords in geometry too? A chord in geometry is simply a line segment that connects any 2 points on a circle's circumference. It's like a tightrope strung across a circus ring. Part of the excitement is that it cuts right through the center of action. Now, let's dive a bit deeper. Every chord has certain properties that make it unique. For instance, the longest chord of a circle is its diameter. That's right, a diameter is just a special type of chord, one that passes through the circle's center. There's another interesting property of chords. If you draw 2 chords in a circle that intersect each other, the products of their segments are equal. So, if you have one chord divided into 2 segments of 3 and 4 units, and another chord divided into segments of 2 and 6 units, the products of these segments, 3 times 4 and 2 times 6, are both 12. Fascinating, isn't it? Now you might be wondering how to find the length of a chord. That's where the Pythagorean theorem comes into play. If you know the radius of the circle and the distance from the chord to the circle's center, you can use these 2 lengths to find the chord's length. Imagine, if you will, a daring tightrope walker preparing to cross the circus ring. The tightrope is the chord. The distance from the ground to the tightrope is the distance from the circle's center to the chord, and the radius is the rope from the center of the ring to the top of the tightrope walker's pole. With these measurements, the tightrope walker could, theoretically, use the Pythagorean theorem to calculate the length of his daring walk. So, from the circus ring to the music strings, chords truly strike a universal note. They're not just elements of geometry, but a fundamental part of the world around us, helping us understand and navigate the circles, literal and metaphorical, that we encounter every day. Angles are not just found in corners, but also in circles. Enter the world of inscribed angles. An inscribed angle, you ask? Picture a circle. Now imagine two lines emanating from a single point on the circle's edge, touching two other points on the circumference. There you have it, an inscribed angle. It's an angle formed by two chords in a circle that have a common endpoint. This endpoint forms the vertex of the inscribed angle, while the other endpoints define a circular arc that is the intercepted arc of the angle. Now let's dive into the remarkable properties of inscribed angles. The most noteworthy is that the measure of an inscribed angle is always half the measure of its intercepted arc. That's right, half. So if you have an intercepted arc that measures 80 degrees, the inscribed angle that intercepts this arc will be 40 degrees. It's as simple as that. And what's fascinating is that no matter where you position the inscribed angle in the circle, as long as it intercepts the same arc, its measure remains the same. It's quite a consistent fellow, wouldn't you say? Now let's bring this concept to life with a practical example. Think of a clock. The minute and hour hands of a clock create an angle. As time passes, the angle between the hands changes, creating an inscribed angle with the clock face. Let's say it's 3 o'clock. The hands of the clock form a 90-degree angle. This means, in our circle world, the intercepted arc is double, hence 180 degrees. Applying this knowledge can make understanding the time a fun geometric exercise. But remember, this is just one application. The world is full of circles and inscribed angles waiting to be discovered. So there you have it, our journey into the exciting world of inscribed angles. It's a simple concept, but one with profound implications in the world of geometry. Remember, time waits for no one, but every hour, your clock creates an inscribed angle. Now that we've understood arcs, chords, and inscribed angles, let's see how they connect. To truly grasp the beauty of geometry, we need to appreciate how these concepts weave together to create a greater mathematical tapestry. Think of it as a puzzle, with each piece, arcs, chords, and inscribed angles, fitting perfectly to reveal a coherent image. Let's consider a problem that involves all three concepts. Imagine a circle. Within this circle, we have an arc, a chord, and an inscribed angle. The chord splits the circle into two arcs, one smaller and one larger. The inscribed angle is formed by two lines originating from the same point on the circle's edge, intersecting the circle at two other points. The question is, if we know the measure of the larger arc is 160 degrees and the chord's length, can we determine the measure of the inscribed angle? To solve this, we'll use a fascinating principle. The measure of an inscribed angle is half the measure of its intercepted arc. So, to find our inscribed angle, we simply take half of the smaller arc's measure. But wait, we only know the larger arc's measure, right? Here's where the puzzle pieces start to interlock. The total measure of a circle's arc is always 360 degrees. So, if the larger arc measures 160 degrees, the smaller arc must measure 200 degrees. Half of 200 is 100, so our inscribed angle measures 100 degrees. See how each concept played its part? The arc gave us the foundation, the chord helped us divide the circle, and the inscribed angle brought it all home. And there you have it, the world of arcs, chords, and inscribed angles demystified. With these tools in your mathematical toolbox, the intricate patterns of geometry become not just accessible, but a playground for your intellect. So dive in, explore, and let the beauty of mathematics unfold. Let's take a moment to revisit our journey through the world of geometry. We started with arcs, those beautiful curved segments of a circle. We discovered how they are measured and how they play a significant role in the formation of circles. After that, we dived into the realm of chords, showing that they're more than just elements of music, but lines segment that connect 2 points on a circle's circumference. Then we explored the fascinating world of inscribed angles, those angles that sit comfortably inside a circle, with their vertex on the circle's circumference. We saw how these three concepts, arcs, chords, and inscribed angles, are interconnected, forming the basis for understanding not just geometry, but the circular patterns we see around us every day. So the next time you see a circle, remember, it's not just a shape, it's a world of arcs, chords, and inscribed angles waiting to be explored. Until next time, keep exploring.